Hey everyone, in this video we're going to talk about volume and surface area. I decided to make this video to go through the formulas and things that you learned hopefully in Khan Academy so that you can use them to then do the project that I'm presenting to you this week, which is finding the volume and surface area of a sandcastle. So in order to find the volume and surface area for that sandcastle, you need to break it into these different shapes and then use the formulas that we've talked about. So volume of a cone, the formula is V equals 1/3 pi r squared h. Now in the sandcastle project, you're going to change pi to be 3.14. So I'm going to also do that here. Now it's not best practice because it's not the exact value, but since we're rounding anyway, and those are the instructions on the worksheet, we're going to do that here as well. So I'm going to rewrite this, but then I'm going to fill in the information that I know by looking at my cone on the left-hand side here. So when I look here, I can see that I have this 8 feet. 8 feet is pointing to this black line here. That means the diameter is 8 feet. So when I see in the formula we're talking about radius, if the diameter is 8, remember the radius is half of that, so that would mean that the radius would be equal to 4. And I'm just going to write that here so you can see it. So the radius is 4. And then the height they actually give me on the picture, I can see that the height is 9. So I'm going to fill those in to the equation over here, and remember I'm going to replace the pi with 3.14. So now I just replaced all that information here, and you can see that it matches the information that was in the diagram. Now, depending on what you're using for your calculator, you may be able to just put this all into your graphing calculator. And if you don't have a graphing calculator, there is a link to go onto the website and use one for free right now during this distance learning time. So you can use that as a reference. If you're going to use your phone, you're going to have a harder time because it won't do order operations. So I highly suggest you either download or use the app or get your graphing calculator to solve these questions. So if I have my graphing calculator, like I said, it'll do order of operations for me, so I can just put this all into my calculator and get the volume. Now, because I rounded the pi to 3.14, like I said, that was just my instruction to you, and that's the instructions in the project. I get an answer that doesn't need to be rounded, but watch out for any rounding rules. Like if they say round to the nearest tenth, then we would have to look here and round the 7, just keep it as 0.7 and get rid of the 2 by rounding. But for this one, there were no instructions to do that, so I'm just going to leave it as 150 and 72 hundredths. Now the last thing that I need to do is put a label on here. Since in my picture I can see that it's feet, I'm going to write feet, but it's cubed because when we talk about volume, the units are cubic. Okay, the next one, we have another cone. So I just brought down my volume formula from up above. Since I know I'm finding volume, same formula. But this time, if we look at my picture, I don't know what the height is. It's missing. But they did draw in this right triangle for us to show that we know that the height makes a right angle with the bottom of the shape. So since this is the height and it's a right triangle, I can use Pythagorean theorem like we did last week to find the missing side. So 18, since that's opposite of the right angle, that makes 18 my hypotenuse. So let's write down off the side the Pythagorean theorem. So that's a squared plus b squared equals c squared. Now, like I said, this hypotenuse was the 18, so I have to put that in place of the c value in my Pythagorean theorem formula. So you can see I just wrote it down below, but I changed the 18 in place of the c. I'm going to also change the a to be my 7. Now, it doesn't matter if you put this in for a or b, because remember, those are interchangeable. Now, b squared, you can either leave it as b squared or change it to x squared. It doesn't matter. Then I can go ahead and simplify these. So 7 squared, that's 49. So then I'm going to write 49. I still have b squared because I don't know what the b value is. And then 18 squared is 324. Now we solve for b squared, and again, this is a review of what you did in the video for last week. When we subtract the 49 from both sides, I end up with b squared equals 275. Then we take the square root to undo the squared so that I know what just the b value is. Now, the problem is when I try to take the square root of 275, it doesn't come out nice. So I end up with the b value, but I'm going to leave it as the radical 275 so I don't make any rounding errors that then follow through with my work. So then I just wrote down my b equals 275. So if you want to put that into the diagram, you can by just putting it where the height is. Now I have everything that I need to plug into my volume formula. Okay, now again, because I'm preparing you for a project where we approximate pi to be 3.14. That's why we're doing that in here. I don't prefer it. I prefer to keep pi in there and then finally round at the very end. So again, this is only because the instructions on what we are doing round it to pi. And additionally, if people don't have access to a graphing calculator, you can use 3.14 a little easier than putting pi or finding a pi button in your regular calculators. So let's go ahead and fill in R with the 7 and H with the radical 275. So then I just filled everything in, so you can see I have the 1/3 still, and then the 3.14 in place of my pi, and then 7 in place of the R, and radical 275 in place of the height. Now, depending on your calculator, again, you can just put this all in your calculator and it'll do order of operations for you. If you don't have access to a graphing calculator, this might be more difficult because you'll have to try to simplify these and then multiply at the end and do order of operations on your own. So when we do this in the calculator, we get 850.4931504. So this time we are going to round, and like I said, because I'm helping to prepare you for the sandcastle project, we're going to round to the nearest tenth. So when I look here at the tenths place, that means I'm going to look at the 4, and we look next to it to see if we need to round. So looking at the 4 and looking next to it at the 9 tells us we need to round this up. So my answer would be, so I have 850 and 5/10, and then I remembered to put the units cubed because they didn't give us any specific units, but I know that since it's volume, it means it's cubic. So this is my answer. Okay, the next one we're going to look at is the volume of a cylinder. So again, we need a formula. So the formula for the volume of a cylinder is volume equals pi r squared h. So then it's just filling in and using the information from our picture. So I can see at my picture, they actually gave me a diameter here of 30. That's across the entire thing. So in order to find the radius, we need to take 30 and divide by 2 because the radius is half of the diameter. So I'm going to replace that with a 15. Then again, I'm just changing the pi to 3.14 because of the instructions in the sandcastle. The radius is 15 and the height is 24. Now it's again a job for my calculator. If you don't have a calculator, you'll have to try to do the order of operations, which remember is PEMDAS, so I'd have to do the exponent before I do any of the multiplication. But if you do have a graphing calculator or you use the link to get a graphing calculator, then you will get the answer of 16,956, and then I'm going to put millimeters, and again it's cubic because we're talking about volume. Okay, the next one is the volume of a pyramid. So again, we need to start with a formula. It's 1/3, and then I have this cursive L that's just standing for the length, and I use a cursive L so it doesn't look like a 1 if I use a lowercase l. You could also use an uppercase L if you prefer. And then the width times the height. And then we just fill in with the information from over here. So the length is 4, the width is 4, and the height is 9. Fill those all in. Then it's again just a job for your calculator. If you have the 1/3 and then 4 times 4 times 9, you will end up with 48 as your answer. And again, I'm going to put units on it, which is centimeters. I can see in my picture, but we have to do cubed because it's volume. Okay, another pyramid question. So since it's the same shape, I'm going to bring down that same formula, but this time if we look, we know it's a square, so that's why this is 10 and this one isn't labeled. So I would be able to put 10 on here, and that's again because it's a square pyramid, so that's how I know that this has to be a 10. But I'm missing the height. If you can see here, this 13 is on the side of the pyramid. That's the slant height. It's not the height of the actual pyramid. So we could kind of draw that in. Okay, now it's kind of hard to see just at the angle that this is, but we know that the height of the pyramid has to be perpendicular, so that's why I put this right angle in here, which means that I can now see this right triangle in here. So I have to do the same thing that we did in the cone where I need to find the missing side using Pythagorean theorem. So again, off to the side, I just wrote the Pythagorean theorem, the a squared plus b squared equals c squared, and then I'm going to fill in what I know. So we know that the height is perpendicular. It also cuts this in half. So that means that since this entire thing is 10, this would only be half of it since it goes directly down in the middle. So this would be a 5, so it would be 5 squared. Similar to before, I don't know what the B value is or one of the sides are, but I do know the one opposite of the right angle, which is the hypotenuse, so that has to be my C value. That one is 13, so I can fill that in. Then I can do all of these in my calculator. 5 squared is 25. I still have the B squared because I don't know what the B value is. And then 13 squared is 169. The next step to get our B by itself is to subtract 25 from both sides of the equal sign to stay equal. And then when I do that, I get B squared equals 144. So now to get B by itself, we're going to take the square root of each side. And when I take the square root of 144, that is actually a perfect square, so I will get 12 as an answer. So that means that over in my picture, I'm going to put a 12 on the height. Now I'm ready to fill in my formula. So then I have volume equals 1/3 of 10 times 10 times 12, and that's just using all the pieces from the picture. When we do that in our calculator, you should get the volume to be 400 units cubed. Okay. The next one is the volume of a rectangular prism. So again, we need a formula. So the volume formula for a rectangular prism, and I'm going to use that cursive L again, is length times width times height. So then I just look over at my picture, the length, and it doesn't really matter which one you want to do. The length I can say 6, the width can be 3, and the height is 4. So then it's just a job for your calculator. You can put 6 times 3 times 4. And you should get 72, and then I'm just going to take my units from the picture, centimeters, but it's cubed since we're talking about volume. Okay, on to a sphere. So again, we need a formula since we're finding volume. The formula for the volume of a sphere is, so the formula is volume equals 4/3 pi r cubed. So again, we can just fill in, and we're approximating pi to be 3.14, so we'll fill that in for pi, and then the radius, if we look at the picture, 10 is the diameter, radius is half, which would be 5. So volume equals 4/3 times 3.14 times 5 to the third power. Again, grab your calculators, put that all in the way that you see it, using parentheses around the fraction to keep it together if you are using one of the older calculators. Otherwise, you can put it in as a fraction. And we get the volume to be 523.3 repeating. So I'm going to round that again to the nearest tenth. So we look in the tenths place, it's a 3. The hundredths place is also a 3, so that tells us to leave it where it is. So my answer is 523.3 units would be centimeters from my picture, cubed, since we're talking about volume. That's it for that one. Now when we talk about a hemisphere for the next example, the question is, what do we know about a hemisphere? Well, it's half of a sphere. So we're just going to use our sphere formula and then cut it in half. So I'm going to put a half in front of the formula we just used. So I wrote down volume equals 1/2, and then I took my sphere formula 4/3 pi r cubed. Now we're just going to fill in everything that we know and have that 1/2 out in front. So at the end, we're going to divide by 2 or multiply by 1/2. So then we can put this all in our calculator again the way we see it. So half of 4/3 of 3.14 times 8 to the third power. Or you can do order operations if you need to. So then when we do that, you should get the volume to be 1071.786667. And then we need to round, again, I'm going to round to the nearest tenth. So the 1071 stays. The tenths place, the 7, if I look there, the 8 tells me to round up, so my answer is going to be an 8/10 or 0.8. And then again, centimeters from the diagram, cubed, since we're talking about volume. Okay, that's it for all of the volume formulas. Now let's talk about some surface area. Okay, the first one is talking about the surface area, which we usually use SA to represent the surface area of a cone. Now remember, when we find the surface area, we're finding the area of all the surfaces. So at the bottom, it might be easy for you to see that that's a circle, and we know that the area of a circle is pi r squared. So we're going to use that for the circle. But then I need to continue by adding the surface area of the outside of the cone, which is kind of difficult to see. So that one is just something that we need to use. The formula is pi r, and then that cursive L, that stands for the slant height. So when I look at my picture, I see I don't actually know the slant height, so we're going to have to use what we did last time with the Pythagorean theorem since it's a right triangle, but I do know that half of the diameter is the radius, so I'm going to put a 4 here. Then I'm going to write my Pythagorean theorem off to the side. Then we fill in what we know. So I have the Pythagorean theorem, a squared plus b squared equals c squared. Then we can repeat that, but fill in what we know. So I know that a and b are 4 and 9. I don't know the hypotenuse. That's the one opposite of the right angle there. So I'm left at c squared. So then we can put 4 squared and 9 squared in our calculators to get 16 plus 81 equals c squared. And then add 16 plus 81. And then to undo the squared, we would take the square root, and that doesn't come out nice, so I'm going to leave it. So then my slant height is radical 97. Now we fill all that into the formula for surface area. I approximated pi is 3.14, the radius is 4, so 4 squared plus 3.14 times the radius 4 times radical 97. Then we can put that all in our calculators using parentheses and making sure that you have it in the way it's written so that the calculator can do order of operations for us. And then you'll get the answer. Surface area equals, and then the 173.941654. I'm going to again round to the nearest tenth, so 173.9. And then our units now are squared because area is squared, not cubed. This is area, not volume. Okay, so that's going to be the same for cone for the next one, just using that same formula. So for this next one, you can see that we don't have to do any Pythagorean theorem. This time it was simply filling into the same formula that we used above. So I filled in the 7 in place of the r, and then the slant height is 18, I can see in my picture. So now I'm ready to go ahead and put that all in the calculator the way that you see it so that your calculator can do order of operations, and you should end up with an answer 549.5, and then it's just going to be units squared, again, because we're talking about area. Okay, on to the next one. Okay, so for the surface area of a cylinder, we need to find surface area. Remember, it's just the area of all the different surfaces. So the easy one is the 2 circles on either side, so we can use pi r squared for both of those. So it's 2 times pi r squared. So that's the surface area for the 2 outside circles on the cylinder, but now we need to find the surface area of the rectangle that would be what would wrap around the circle to make the side of the cylinder. If you think of like undoing a soup can label, that's what we're looking for. So in order to find the length of that, we need to do the circumference around the circle because that length actually goes around the circle. So circumference. So that's pi d. You can also use 2 pi r for that, but pi d is the equivalent, and then just the height of the rectangle. So I wrote the h there. Okay, now we're going to repeat this, but now I'm going to fill in the information from our picture. Okay, so from my picture, I took all of the values that I knew, plugged them in, and approximated pi is 3.14. Then it's a job for our calculator to get the total surface area, which is 3,673 and 8/10 millimeters squared, again, because we're talking about area, the units is squared. Okay, on to the next one. Okay, so the surface area of a pyramid. So for a pyramid, we need to find the area of all the different faces. So we've got the base, which is a square, and then 4 triangles on the 4 sides here. So I need to find the area of the bottom, and then the triangle, multiply that by 4 to fill in all 4. So off to the side here, you can see I just did, okay, so length times width for the side, the square, which would be 4 times 4, and then 4 of the triangles, which is 1/2 base times height. So in order to do this, I need the height of this triangle on the side here. If you can picture that, well, that means I actually need the slant height of this triangle in order to fill in the height there. So I need to use Pythagorean theorem again. So here you can see I have the 2, because that's half of this right here is 2. So I'm going to do a squared plus b squared equals the c squared, the slant height. So 9 squared plus 2 squared. So then I have the formula filled in off to the side. 2 squared plus 9 squared equals c squared. 2 squared is 4. 9 squared is 81. And then c squared I don't know, so we leave that. Then 4 plus 81 is 85. And then I can take the square root to end up with c by itself. So now I know the slant height is radical 85, so I can put that in my formula. So hopefully you see where I filled in everything into my formula. Then we can put it in our calculator or break it down if you need to using a calculator that doesn't do order of operations. So then we should end up with 89.75635566, which rounds to 89.8 centimeters squared. Okay, how about the next one? This next one is easier because the slant height is already known for us, so all I have to do is fill in what I know in the picture. So you can see the same formula to start with. Surface area equals length times width plus 4 of the triangles. Then fill them all in. So hopefully yours matches mine. You get the 10 times 10 plus 4 times 1/2, 10 by 13. When you do that in your calculator, you should get a surface area of 60 units squared since it's area and there's no units given. Okay, whenever we find surface area, we're finding the area of all the different surfaces. So since all of these surfaces are rectangles, it's going to be kind of hard to look at a formula and fill it in. So I'm just going to fill it in as we talk about it. So for this example, the base is a 6 by 3 rectangle. So I'm going to do 2 times and then the 6 by 3. So we can see that 2 of the 6 by 3 rectangles. And that's why I have the 6 by 3 in parentheses to show that it's that rectangle. Then I'm going to do the same thing for all the other sides. So 2, the sides of the box would be a 3 by 4. So 3 by 4 or 4 by 3 either way. And then the last one is 6 by 4. So hopefully that makes sense to you of how you fill them in. You just find the area of each of the sides, but there's 2 of them. Since it's a rectangle, opposite sides will always be the same area. So then we can add all those up, put this in your calculator exactly the way you see it. When we do that, we get 108 centimeters squared. Okay, now the surface area of a sphere. So the surface area of a sphere, the formula is the surface area equals 4 pi r squared. So then let's just fill them in with our approximation of 3.14 for pi and our radius, since the diameter is 10, our radius would be 5. So filling in all those pieces of the formula, we have the 4 times the 3.14 for our approximation of pi times 5 squared. You can put that all in your calculator and you'll get 314. And the label would, again, be centimeters squared since we're talking about area. So using the same idea, how can we find the surface area of a hemisphere? Well, if a sphere is 4 pi r squared, a hemisphere would be half of that. So the surface area for a hemisphere is 2 pi r squared. The same idea, we'll just fill in what we know. So now I have surface area is 2 times the 3.14 times the 8 squared. When we put that in our calculator, we end up with 401 and 92 hundredths. And then again, centimeters squared since we're talking about area. The last thing I want to show you is just this example of a more complex volume surface area question. So for this one, if we were asked to find the volume, we would be able to find the volume of the cube or rectangular prism on the bottom here, and then the volume of the pyramid and add those two volumes together. If we're asked to find the surface area, remember that you're only looking for the surfaces that we can see. So like if I were to wrap this in wrapping paper, if you can think of it that way. So I would need the bottom of the rectangular prism. I would need all 4 of the sides, but not the top because it's not visible. And then for the pyramid up here, I would need to find only the 4 triangles since the bottom is hidden. So those are the things you're going to use for your sandcastle project. I'm hoping that you can use this video as a good reference to help you through the sandcastle project. Thanks.